this. Look, today's call is about profiling a project that we've done with AMPC on our salted hides and automating the palletising. What we're going to do today is we're going to hear from Scott Technology, who ran the project and installed the equipment, and get an overview from the technical side of what they did, and then using one of the other technologies from Rename's PC projects and Bondi Lab smart glasses, we're going to get Murray Wilson, our operations manager, to do a walkthrough and show you how the hide facility works and the installation. We wanted to use the glasses technology to show, do a remote profile of this type of event as well. So tick a couple of boxes. So thanks to everyone. Big thanks to AMPC, obviously, for the funding and the support for this project. And I hope everyone gets a bit out of this. So with that, I might hand over to Nick, who's going to do the Scott's Technology intro and overview.
Yeah, sure. Okay. Thanks, Michael. I've thrown together a few slides which I might just throw up on the screen to run through, which you should be seeing about now. Can you see them, Michael?
We got them, mate.
Yep,
yeah,
excellent. Come up. Thank you.
Yeah, excellent. Look, I threw this together in a bit of a hurry, but I've just sort of tried to cover off some of the key aspects of the technical side of the hide palletizer. I'm sure there'll be a few gaps. I've got Merv also on the line, who was project manager for the system, and I think Andrew Arnold may have dialed in as well. So he's from our New Zealand factory, was heavily involved in overseeing the build. So Andrew's our director for MEAT. Merv's one of our project managers in Sydney, and I'm based in Sydney. I do sales and development for all the meat related technologies. So look, Scott's, I think you probably have I don't know whether, I assume everyone on the call's got a reasonable idea of who Scott's are. We're a global company across, we do a lot of our meat business in Australia and New Zealand. We've got about sort of 150 odd people in both Australia and 150 in New Zealand. Meat's one of a number of different industries that we develop equipment for. We do a lot of equipment in appliance automation, mining. We've got expertise in materials handling and logistics and automated guided vehicles. So a lot of the industries overlap. We're bringing a lot of the materials handling technology to the meat sector as we speak. So it's an area which we're growing in. Within meat, we operate in all the sort of key protein sources, so the lamb, beef, chicken and pork, and you can sort of see diagrammatically there. I mean, we're very much focused on the processing sector. We're developing technologies throughout the process, each of the processing sectors, and we started out our meat development in lamb, and so we've got quite a lot of equipment developed for lamb at this stage, and we're now starting to move on to developing equipment for beef. So obviously this hide palletizer is one of the earlier developments for us in beef, and we're just embarking on progressing our automation in the deboning of beef. So I think you guys are probably all familiar with the first rib scribing system that we got operating up in Denmore, but over the next sort of 12 to 18 months, we're building up the next generation of beef automation equipment. So it's really sort of going to take it to another level. So it's an exciting time for us, and it'll be an exciting time for the industry, hopefully, as we start to roll that through. I guess, and this is all this slide here. I bring this up from time to time, so a few of you may have seen this, but I guess the key message there diagrammatically is that obviously we're very focused on the processing part of the value chain. From our perspective, and these are all sort of figures which we sort of plugged away and got to ourselves, but from our perspective, there's a lot of value to be gained within processing through both concentrating on where your biggest costs are, and where you get the greatest amount of your revenue. So obviously the livestock inputs and maximising the red meat cuts that you get out the back end. There's also a lot of other value to be picked up in things like offals and hides and value adding, and obviously in automation there's a lot of opportunity to pick up in labour replacement as well. So look, this I guess the message there is, we're very focused on that processing sector, and we want to target it. We're building up technologies to try and target those key areas where we can add some value. So really the rest of the presentation is all just focused on hide processing. I'd love to talk to you some more about some of the other technologies we're looking at, but in terms of hide processing, it started out when talking through with JBS originally. Obviously it's an area which is highly manual at the moment. There's a high concentration of labour. It's an area because of the wet, salty, slippery nature of the facility. It can be quite dangerous. There's forklifts running around and quite heavy loads to be picked up and placed onto pallets. So it was an area which had sort of drivers from both the labour replacement aspect, but also the OH&S aspect by and large. And look, when we spec'd out this system, and acknowledging, I think when you go through certainly the hide facilities that I've been through at various different processes in Australia, they're all very, very different from each other. But in this particular instance, and obviously this system was spec'd out for this particular instance, there's a significant labour component which can be replaced. I think that same principle applies, but in different ways at different processing plants. So, but what we've found is, I think the underlying technologies that we've come to will be quite applicable across the other processing facilities. So the system at Dinmore is designed around running up to sort of 450 hides an hour, palletising 450 hides an hour into sort of 10 different pallet bays. With hides of sort of between 20 and 80 kilograms, those salted hides. Obviously, embarking on a project like this, it's sort of a bit of a first of its kind. There's a lot of risk. Obviously, it's not like palletising anything else that you find within the industry or across other industries. So we did a lot of work early on around trying to mitigate some of the key risks, as you can imagine. Getting the different sizes, heights, weights of the hides, the way they hang off the pallets, and when they land on the pallet, the way they structure on the pallet. There are a lot of different challenges. So we did some early stage trials just to try and get some concepts. And one of the key things, I've just got a video there which I'll turn the sound off on, but one of the key things that came out of that was this end effector design and the way you pick up the pallet, which I'll come to in the hide, which I'll come into in a second. So from that, one of the couple of key things that came out of it was that end effector, being able to effectively get under and support the full range of hides, and also be able to get into and on top of a pallet and be able to place the hide effectively. So there was quite a bit of early stage work around getting that right, and an early stage prototype end effector is shown in the top right there, and there were various concepts. This is one concept which is shown here, but essentially what the system we were looking at. So after we did that original work, we looked at how we spec out a system for within the Dinmore plant, where it fits within the process. You've got hide grading up the front. So this is whilst there's hides that are presented on a moving chain, which I'm sure you're all reasonably familiar with. Hides are graded. There's various different grades. I think there's five basic grades, and then there's some sub grading within that. The hides are then laid down on a table to be these tables are part of the system. The hides are verified, and then the hides are all with a grade attached to them, sent into the system so that they can be palletized into. And in Dinmore, there's a series of 10 different palletizing bays. And then from each of those bays, once the bays are completed, so once the pallet is completed, there's a roller door that lifts automatically, and hide packed pallets are able to be removed using forklifts. And obviously, Merv, just jump in if you have anything to add, but that's the sort of basic where it fits in within the process. So this is sort of diagrammatically the broader process within the Dinmore facility. So you can sort of see where it is difficult to see actually, but these where these hung hides come around past the Y-scale hide compactor, and through the hide ringer. We did set up the system with the ability to do some manual palletizing as well. So obviously, in the process of commissioning a system like this, production's got to continue, and also for all of the odds and sods, which after you've got the automated system running, anything outside that you want palletized as a special case, you can still use a manual area to palletize. And then you can sort of see where those pallets are, and then there's a set of racking which you can use the racking to store the pallets. So within the machine, there's a series of what we term pickup points for where the gripper comes through. So you can sort of see in this photograph on the right, there are 2 carriages which traverse up and down this gantry. They have a gripper on them each, so there's one gripper for each side of with each of these transfers, so two linear transfers. You can see where this was set up in commissioning stage, and there's some packaged up hide material to pass through it. But you can see these are the pickup locations. So there's 14 pickup locations, and the system automatically detects which grade it is and picks it up in the position that's efficient for packing it onto each pallet. So I mean, like I mentioned, the cycle rate for the machine, it runs up to 450 hides per hour, which means it's got about an 8-second cycle time hide to hide. It's got various different grades and rejects that it works with. The hides do vary a lot in size, but by and large, there's a couple of different standard sizes. So there's this 950 and size hide, which so min and max. As you can see, there's probably 100 mil worth of difference in length and same in width, and the height varies by a bit more. So you can see here on the diagram on the left, the gripper, which is at the bottom of those traversing carriages, comes in. A set of forks go underneath the hide and grip it to place into the pallet. And so I thought I'd just as well. I've got a wee video here, which it's a video which is on YouTube, so you can view it after this. So we won't go. So I'll just play it.
So Nick Murphy here. While this is going, I just add a few things in this. This video is taken when we have been doing FAT of the system in Dunedin. The 2 grippers working at the same time. And we proven in that stage that we exceeded the cycle time that we supposed to have 450 per hour to 520 an hour. The challenge for this is that the operator that gotta fold the hides, they gotta be able to catch up with that rate, which usually I think is the situation that they cannot, which is outside this. So if they can do that, the system can do it to 500, 520 an hour. The biggest challenge in the project in terms of is the high salt content of the product, which everything is designed with stainless steel grade 316 marine grade to make sure that it can handle that salt content. And that applied to a lot of components in touch with the product. And the other challenge was the fat content and the slippery nature of the product to make sure that we are not dropping that while we are handling it from A to B. The project installed in a very short period of the time while the site was in operation. Yeah, that's some of the.
Yeah, and I guess, yeah, thanks, Murph. Thanks for that. And I guess one of some of the other key things to sort of take note is that, yeah, we designed up this system as being a gantry style system for a couple of reasons. Obviously, there's the number of pallets which we had to grades that we had to palletize to lends itself to that sort of length, and also that sort of throughput lends itself to having those two heads. But I guess the key, as I sort of pointed out in that earlier slide, I mean, one of the key bits of technology in here is really how we pick up and place those hides onto pallets with these end effectors, and the way we can place them in a pattern on the pallet. So what it does enable us to do is when we go to other processing plants, we can customize a solution which is suitable for every sort of size and shape of palletizing. So if you're only palletizing, for instance, onto a couple of different pallets, you may not use a gantry like this. You might just use a robot with a end effector. If you've got more different lots more grades but at a lower rate, you might use, for instance, this gantry style system but only have one stream of product. So I guess in terms of, you know, one of the key things that came out of this original project, it gives you those building blocks to be able to spec out a system which is suitable for all the variety of different plants that are around Australia. So I mean, that was one of the great outcomes from this system. And I guess the other key thing at this, it was essentially finished up, or sorry, completed March 2020, which was an unfortunate time of for everyone. But it means that the system's been running. It's been getting hours across it, and you know, there's been bits and pieces that have come across the way, but it's given us an opportunity to be able to build you know, reliability into the system and really sort of leverage the learnings we've had from being able to operate for that sort of period of time. So that was essentially all I had on my slides. So
yeah, thanks for that, Nick. That was really good. I guess
Andrew, did you have any? Sorry, I was just going to say, Andrew Arnold, did you have anything further you wanted to add to that?
No, you covered it really well, thanks, Nick. But the only thing I would say is that reinforcing the reason for the gantry style 316 stainless design was driven by the specifications from JBS not wanting to have anything that would potentially cause rust or not be able to stand the environment.
Yeah, sorry.
Thanks, mate.
Can I just add a few things? Is Murphy? As you see, there is 8 compartments there that we can grade to 8 different products. Robot tracking them from the time that is folded. On the folding session, there are some load cells that we weigh the size of each hide, and also we dimension them. If they are folded wrong, we reject them. And there is 2 pallets at the end, which is for rejection, just in case for any reason gripper cannot lift them. Another thing that we implemented is that as soon as the garage door of those compartments open, we can track them from that point to the presses. So because all the information of each pallet is in the PLC, and from there a label can be printed and go in top of that. And then from there, tracking can happen that between that point to the press, we don't lose the tracking of which product is in which pallet. That's a tracking after the product leaving the cell. Thanks.
Thanks, Murph. Yeah, so Greg, unless there was anything else we had to cover, we probably can, wrap that up. I hope people enjoyed that. We'll have that video available anyway. We'll be able to share that with some of the other industry participants who couldn't get on today.
Yeah, that's brilliant. And thanks, Michael. Thanks to Scott for their contribution today. Very beneficial to set the scene before going in there, and very more importantly, thanks to the JBS team. That was fantastic, and I think a very good use of technology to show off other technology. Yep. And a good recovery for the audio.
Yeah.
That was brilliant. Thank you.
Got to be nimble. Thanks.
Phone.
Yeah,
Mobile
thanks.
phone.
Thanks, Murray.
Thanks very much, guys.
Thanks, everyone else
Thanks,
online.
everyone.
And thank you, everybody.
Thank you.